So the new gas law we're going to talk about is ideal gas law. Ideal gas law only deals with one set of conditions, and the formula is PV equals nRT, where P is pressure. This is always an ATM. V is volume. In this case, this is always going to be in liters. N is number of moles. R is known as an ideal gas constant. So this is a constant, which means it doesn't change. And it's 0.0821. And the units of this constant is liter ATM over mole Kelvin. In other words, all these are the units of this one number. T is always temperature, and we already know that that's in Kelvin. So now we're going to plug into PV equals nRT and solve for one of the variables. Obviously, the only variable you'll never solve for is R, since R is the ideal gas constant. So let's do a few problems. So this is what it looks like if we're solving for pressure, right? If we're solving for volume, basically this worksheet just gives you a bunch of the variables isolated, okay? So we're going to start with this one problem where it says a tank contains 115 moles of neon gas. So what is this 115? Well, we know that 115 is N. So we're going to designate this N. It has a pressure of, so you know that's P. Temperature is 45. Well, then what do you do with that? You take the 45, remember you add 273. And it says to calculate volume. Okay. So let's go ahead and take these. Okay, so N is 100. We're going to plug into PV equals nRT. We'll do 3 columns. We'll do given. All right, so pressure is equal to, volume is equal to, N is equal to, R is equal to, well, R is always the same. And then T is 45, but you add 273. N is 115, and pressure is 57. 115 moles. And this is 57 ATM. So now formula, just like we did before. PV equals nRT. And then we're going to plug in. We make sure this is ATM, that's moles, this is Kelvin, and that has its own set of units. So 57 times your unknown is equal to 115 times 0.0821 times 45 plus 273, which is 318 Kelvin. So now we're just going to go ahead and multiply the 115 times 0.0821 times 318, and that is divided by 57. V will be 52.7, and this will be in liters. Okay. All right, so let's go ahead and try number 2. Scuba tank has a pressure of 195. So what is that? That is P. Temperature is 10. Remember, you add 273. Volume is 350. So now this is liters. How many moles, right? So now what we're going to do is we're going to solve for, moles, which is N. So this is number 2. Again, PV equals nRT is what we're using. You list the given. Pressure is 195 ATM. Temperature is 283 Kelvin. Volume is 350 liters. R we already know. 0.0821. And now in this case, we're looking for N. So plug in and solve. Same way as before. 195 times 350 is equal to N times R, 0.0821, times 283. Okay, so you do the math, and N should give you, so you do, in this case, it's going to be 195 times 350, right? That's separate. And then we're going to take the product between the 0.0821, 0.0821 times 283. That gives me 23.23. So I'm going to take the product between 195 and 350, which is 68,250, and I'm going to divide that by 23.23, which gives me 2,938 moles. And that's all there is to it. You just plug in and make sure that you have the right units, and after you plug in, you just go ahead and isolate. You can go ahead and isolate the formula, the variable prior to, like this. So you can go ahead and do that in advance and then plug in. It's up to you. It really doesn't matter. We're not going to use PSI. So even though it gives you some PSI problems here, we're not doing PSI. So where it says, what is the pressure in PSI? Just ATM. 850 ATM. We're not using PSI. So I want you to go ahead and do numbers 3 through 7 on a separate piece of paper or in your notebooks. Doesn't matter. And then I will check those on Thursday. Along with, there's also another worksheet that's posted under assignments that is also part of your classwork. That is all due tomorrow. And have a wonderful day. I will see you tomorrow.